Hi, everyone. Welcome to Foresight's Gaming the Future book club. Really happy to have you all here. This was, I think, a session that many people have been long looking forward to, and that I think is the one session that we probably referenced the most in the previous sessions. And, like to bring people up to speed, we started the book really with pointing out like the value of voluntary cooperation. Then we discovered basically how those systems evolved, how we can kind of currently build on remote legacy institutions, how we can improve them with crypto, mostly focused on human cooperation. And now we take it kind of up a notch and gradually discuss what does it mean to bind artificial intelligences into the mix. There's a few, pretty, I think, like prevalent, um, you know, like A, progress has been speeding up a lot, and B, there's been a few, more prescient recent um, publications and just worries and concerns about AI. And so I think it's a pretty timely session to have now, actually. And yeah, I'm really, really happy to be joined here by Trent McConaghy and Steve Omohundro. Before we go into the normal chapter discussion, Steve will be presenting on his view on personal AIs, which I'm also going to share a little bit more about here in the chat. I'll share a few links to your resources. But yeah, I think like Steve definitely needs no introduction in the field. Has worked both at the intersection of the crypto commerce field and AI for a really, really long time now, and has done really fantastic work. And then we have Trent, and I'll be interviewing Trent on his concept or his ideas on AI DAOs. And both those, I think, both Trent and Steve have this really great ability to, I think, bridge the decentralized crypto divide with the more, the more I would say, standard views on AIs. So it's really, really exciting to have you guys here. Thanks a lot for coming. And Steve, without further ado, the stage is yours. I'll share more info about you in the chat, and then we'll lead into an interview with Trent. Welcome, Steve.
Great. Thank you so much, Allison. You mentioned personal AI. I'm happy to talk about that, but I actually made some slides just about more generally what's going on right now with AI. Where is it likely to go? What are some of the trends? And how can we achieve the kind of...
Steve, your audio is choppy.
Oh, okay. Let's see.
It's okay for me.
I don't know what I can change here.
Yeah, the audio is fine for me.
Okay. Let me turn down my own speakers and see if that helps. Is that better, Mark? Can you hear? Well, let me just go ahead and pipe up if it's bad. Yeah, and how do we actually achieve the cooperative technology we've been talking about here? And I'll give my take on it. I would love any feedback and so on. It's maybe about 15 minutes. I put the slides in the chat. So there are a bunch of links in there to various papers and things. So right now, the AI is really being driven by transformers, but large language transformers is sort of revolutionizing all over the place. And just to sort of have the context, here's the circuit diagram for these. This is the circuit diagram that's changing the world at the moment. And this is the GPT style transformer where you have some words coming in over on the left column, and it's trying to predict the next word. And it's organized as a series of layers, and each layer just has two types of operations. The first is called self-attention. It's basically looking at neighboring layers. The second is multi-layer perceptron, and that's where the knowledge is stored. People don't really understand exactly how this works. There's a lot of work going on trying to analyze it, but they're doing amazing things and all sorts of things. And so here's a little bit sort of the history of this revolution. It really started in 2017 with the Attention is All You Need paper, which applied this to translation. 2018 came BERT, which is just the sort of encoding portion of that. And both Google and Microsoft started incorporating it in their search engines. 2018 saw GPT, GPT-2, GPT-3 coming from OpenAI, which is the generative kind of language model. And in 2020, Google did T5, which combined both the encoding and the generative models. 2020, people started applying it to vision problems. The vision transformer started doing state-of-the-art there. 2020, it also got applied to theorem proving, the OpenAI GPTF program. 2021, we had AlphaFold 2 using transformer ideas with other ideas also for protein folding very successfully. 2021, we had codex code generation, systems like this that automatically generate code based on little descriptions of the task. Also in 2021, we had decision transformers, where these techniques are starting to perhaps replace reinforcement learning for solving decision problems. In the last month or two, we've seen just a whole slew of amazing new systems coming out based on this core technology. Google had Flamingo, which takes as input images, video, and text, and it can make good, reasonable commentary on it. The Palm model is currently the largest dense language model based on this technology, and it's just doing amazing things. It's showing new capabilities that haven't been seen in smaller models. And then Gato is a single transformer, which does 604 different tasks, including manipulating physical robots, playing Atari games, commenting on images, all with the same transformer model. And that has a lot of people buzzing about, oh my goodness, is this the beginning of AGI? And so it's very exciting times. Transformers still have a lot of problems. They have a tendency to lie, to confabulate. They don't have memory in their simplest form. And so they're sort of like the lead character in Memento, that movie, where they only remember what's happening recently. They can't give attribution for the things that they say. They will generate toxic speech and biased speech. They have very poor reasoning. They don't have a good model of the listener, and they're very expensive to compute. But every one of these, there's a whole bunch of groups all over the world trying to work on it. There are ways to connect transformers to databases so that they can look things up in the database and they can tell you, say, give a Wikipedia reference to something they say. So that gets rid of some of the confabulation. There are memorizing transformers, which build up a memory. There are things which try and avoid toxic speech. Reasoning is an area that's of great interest and great importance. They discovered that just by modifying the prompt, if you put in the phrase, let's think step by step, that dramatically improves the reasoning capability of these models. And then there are groups trying to build listener models and many, many variants which are better computationally. A really striking result came out in 2020, again from OpenAI, that these transformer models obey very regular and precise scaling laws. That if you try and estimate the loss of these models as a function of the compute, of the data set size, or of the number of parameters, they're power laws and very, very regular. And since that time, the larger models seem to fit right on these curves. So that was very interesting. That's significant because it means if you want a certain performance, you can figure out how much compute you're going to have to budget for that. And so that has really, I think, driven OpenAI's planning for the future. People now applied it to vision as well. Vision laws have their own power law. Vision models have their own power laws with a different exponent, but very similar. Similarly for game playing, similarly for theorem proving. And so these scaling laws are sort of shaking up a lot of people's thinking. And you can project forward. When do these scaling laws predict that we'll hit human performance in various tasks? And most of them, it's say within a factor of 100 or 1,000, and it's roughly, a decade, something like that. So that sort of suggests we're coming close to significant AGI. You can also look at, well, what is the computational power of the human brain? Open Philanthropy did this very nice study using 4 different aspects of the biology of the human brain. And their conclusion was that the human brain appears to do about 10 to the 15th flops as the median sort of estimate, and it's very unlikely to be doing more than 10 to the 21 flops. So that range sort of tells us where we're at. How does that compare to current compute? Well, NVIDIA is just about to release their Hopper AI engine, the H100, which they claim has 32 petaflops, or petaflop is 10 to the 15th flops, of floating point 8, which is sort of a little bit of a limited thing, but maybe comparable to the brain thing, for $249,000. So it's almost surely that this system is powerful enough to do what the human brain does if we have the right software. And so that also suggests we're sort of in the compute area, very close to powerful transformative AI. So people are very interested. When is this going to happen? And they're making various bets and all kinds of online, back and forth, Gary Marcus versus, other people. And so the prediction market Metacalculus has 2 markets running, one on sort of a weekly general AI, very powerful, would be transformative possibly, but maybe not as strong as full AGI. And that one, the prediction is currently at 2028. And then they have a stronger one, which is more like full AGI, and their predictions at 2038. So, who knows? It's a market of people betting, but it gives you a sense that sometime in the next few decades, we're likely to see transformative AI. There's a range of people who think it's not coming soon or ever, and some who think it's coming soon, some who think it's going to be really good, and some who just think it's going to be really bad. In the lower right corner here, we have Eliezer Yudkowsky, who's the head of Mary. He thinks it's coming very soon, and it's going to be very bad. On the upper right, we have Sam Altman, the head of OpenAI. He thinks it's coming really soon, but it's going to be really good. And then over in the lower corner, we have Robin Hanson, who was on this group a little while ago, and he thinks it'll be a long time and that it won't be so good. And then up here, we have, Gary Marcus, that he thinks it's going to be a long time, but that it'll basically be good. So this is the sort of discussion and dialogue that's going on out there. How do we prepare for this? A number of years ago, I wrote a paper called The Basic AI Drives, which is if you have a free rational agent AI that's very powerful, then for many goals, it will develop universal sub-goals. For example, self-preservation. And the story people sometimes tell is if you make a robot butler whose job it is to serve coffee, it will try and keep itself from being turned off because you can't serve the coffee if you're dead. Similarly, these systems will try and get resources because most goals do better if you have more resources. They'll do self-replication because more copies lower their risk. And they'll try and preserve their goals because from their current perspective, that's what they want to do. So all of these are sort of just natural outcomes with very little reasoning. And some of the current language models are starting to exhibit some of these things, which is quite interesting. These could be harmful in unexpected ways, and if they're misaligned with human interests. And so a lot of people now are working on alignment. That's sort of the phrase, which is try and build these AI systems with goals which are aligned with what humans care about. I think that's great. I'm all in favor of that. But I think as we've been discussing in here, in addition to that, making systems that want to do good things for humans, we also need to create a safety infrastructure. We need to make sure that there aren't temptations to do bad things. And so how do we do that? How do we build a safety infrastructure? I propose something called the Safe AI Scaffolding Strategy for this, which I talk a lot about at this website down at the bottom. But it seems to me humanity basically has three superpowers we can use to control powerful AIs. The laws of physics, things like the speed, you can't go faster than the speed of light, you can't create matter and energy out of nothing. There are limits on memory, compute, and communication. Mathematical proof, where we can prove properties of different model systems, and then cryptography. Cryptography, is fundamental to our current world, fundamental to the blockchain, and we've talked a lot about it here. It's also on the verge of crisis. There's something called the quantum apocalypse, that if quantum computing gets a little bit better, it will probably destroy all the current public key technologies. And there's a variety of post-quantum public key technologies that are coming out, but they're looking pretty weak. Just last week, 3 of the 6 proposals for post-quantum public key have new vulnerabilities in them. Symmetric key looks a little bit stronger, but we still don't have a mathematical proof. And so in the face of very powerful AIs, that's a bit worrisome. The one-time pad is the oldest cryptographic system that's been analyzed, and that's provably secure. And in fact, it's the only provably secure system. So some friends and I are trying to figure out, can we use one-time pads to do much of what we want from cryptography? I think of these 3, mathematical proof is our real powerful tool. And we've talked a lot about in this group how to use it. We had a wonderful talk last week about how do we use proof to make software better, to make things more secure, to make our infrastructure better. So I thought I'd give a sort of overall, view of what does it mean to have formalization? What does it mean to have proof? And how does this fit in with AI? Natural language actually encodes almost all of the elements of formal reasoning and formal proof, but in a kind of informal way. And so human language was invented somewhere around 150,000 years ago. That's really the beginnings of formalizing the world. Aristotle tried to make those rules precise in 350 BC. Euclid introduced the axiomatic method and did it for geometry in 320 BC. Boole in 1854 created propositional calculus. Cantor started set theory in 1874. Frege invented first-order logic in 1879. Axiomatic set theory started in 1908. And we had the full Zermelo-Fraenkel set theory with the axiom of choice in 1925. That's the current foundation for mathematics. And that is sufficient to encode all of current physics, all of current engineering, all of the current computer science. Gödel showed some limitations on these systems in 1931. We had Turing in 1936, who formalized computation. We had Church, who formalized functional computation in 1936 also. The typed lambda calculus showed up in 1940, which is an alternative system, alternative to set theory. The first theorem prover was the logic theory machine, which did propositional calculus in 1956. The first order provers came in the 1960s. And the idea of NP completeness came in 1971, and people suddenly felt like, oh, maybe theorem proving isn't going to be so easy or possible. They started moving toward proof checkers. The LCF proof checker came in 1972. In 1992, there were a whole series of SAT solvers, sort of propositional solvers, but for NP-complete problems, but surprisingly easy to solve. In 1993 came the QED manifesto, which argued that all of mathematics should be formalized and machine checkable. And in around 2000, we had a whole bunch of proof assistants, which are in use today: HOL, Mizar, MetaMath, Cope, Lean, Isabelle, and various chunks of mathematics have been encoded in these. And just to give a flavor of it, MetaMath is one that is based on Zermelo-Fraenkel ZFC. And its proof checker is very simple, 300 lines of Python code. There have been about 38,000 theorems proven in this. Roughly, I would say an undergraduate mathematics degree. The De Broglie factor, which is how much bigger is a formal statement of something versus, say, the textbook statement, is about a factor of 4. So pretty simple. And over on the right here, I have the entire formalization of ZFC. This is propositional calculus. Here's first order calculus, and here's the set theory. And this is a direct transcription from their encoding in ASCII. So it's a very clean, simple system, and it's formed the basis for many of the theorem provers. So starting in 2020, these big, large language transformer models have been applied to the task of theorem proving. And GPTF from OpenAI was able to train on about 36,000 MetaMath theorems, and they were able to prove about 56% of the held out theorems. A few months ago, the Hypertree proof search system was published, which is an AlphaZero style MCT markup chain tree search transformer. And it's on online training, it's able to prove 82% of MetaMath and about 58% of Lean, which is another theorem prover. So those are quite striking and amazing results. Christian Zaghetti is at Google, and he's heading they recently published a paper on auto formalization, which is taking, math books and computer manuals and language manuals and creating formal models directly from them using language models. And he says he's willing to make a bet that by 2029, they'll have systems which are on the same order of mathematical competency as strong human mathematicians. So that's a pretty striking statement. So just to conclude, I would say our takeaways here are that powerful AI looks like it's likely to come in the next few decades. This will be a transformative event for humanity. Mathematical proof is our best tool for making this AI safe and trustable. Good theorem proving and auto-formalization and so on looks like it's going to be likely within a decade. That this is likely to cause a flurry of provably correct AI-generated software, hardware, engineering, a wide range of things. But to make sure all of that is safe and fits into human society in a good way, I believe we need to design provably safe cooperative infrastructure along the lines that this book is all about, that makes use of these new powers. And I think we should start designing them now before the theorem provers are here, under the assumption that when they do show up, we'll be ready to deploy them to build a safe infrastructure. So that's the story.
Wow. Wonderful. Thank you so much for bringing us up to speed on, why do we even talk about AI? That was really great. I also love the little crowd runs. I think there were so many recent interesting Twitter posts where people try to group people and then did new regroupings of where people stand in terms of timelines and how optimistic they are. So thanks a lot. Without getting too much into the discussion yet, because we also, or at least I would love to hear a little bit more also from your own personal AIs, more as a potential safety strategy. And I want to quickly give the stage to Trent, because I'm not sure how long time you guys have. So I just want to make sure that, for the time that we are all here, we at least get to hear the kind of like the tidbits, and then we get into the discussion. Okay, Trent, I made you co-host just in case you want to share images as we go along. I know that, what I really love about your post, anyway, like in general, people, I think should really check out Trent's blog post series. I think Trent writes really prolifically, very crisp, short, and usually with really good imagery as well. So Trent, thank you so much for joining us. I have a few questions here that, I would want to ask you. There's basically, I think you, then Ali Yahya and Fred Erzam wrote like at least a series of related blog posts. I'm going to try to share them all here. That is trying to think a little bit about how the emerging Web3 space can contribute, or like what happens when AI meets the emerging Web3 space now and in the longer term future. So you wrote this really wonderful series on AI DAOs. And the first question that obviously is striking is, what are AI DAOs? Can you bring us up to speed on, like, what can we expect there? What makes them so powerful, and how would we get there?
Sure. So thanks everyone for having me, and great to be here. And in general, I don't have time constraints. It's a Sunday evening here in Berlin, Germany. So happy to join in the discussion later too. First, I think let's talk about DAOs. The DAOs you might hear about in blockchain land these days tend to be a very specific type of thing. It's typically a group of 20 to 150 people that get together that think that there aren't rules, and it's kind of anarchy, right? But they're definitely Dunbar DAOs, limited by Dunbar's number. There are other DAOs though too. Overall DAO is short for decentralized autonomous organization. And Bitcoin can readily be called a DAO. It's decentralized, it's autonomous, and it's an organization in that it is coordinating humans. And overall, basically any blockchain system that has incentives is coordinating humans and can be framed as a DAO. And it's sort of like the definition of life or the definition of AI. Throw a rock at a different, and you'll find a different definition. 20 rocks, 20 different definitions. But there's correlation, and having a few definitions, I think, is useful pragmatically, right? So same thing with DAOs, but practically speaking, there's probably the two most common ones right now are protocol DAOs, whether it's Bitcoin or Ethereum, otherwise, or Dunbar DAOs. You can also, though, think about a DAO as simply a technology that is used to help coordinate humans. And how could that group of humans be shaped? It could be shaped like a soccer club. It could be shaped like a top-down corporation. It could be shaped like a city or a family or a country, or a co-op. And it could be a small co-op or a big co-op. And then the DAO technology is there simply to help coordinate. Rather than using pencil and paper, you now have decentralized network with state, with digital signatures and other cryptography tools. So basically, it's a community with a very low friction wallet. You don't have to go and open a bank account together and sign a bunch of wet contracts. You have crisp, dry code contracts. And so that's the main thing that's really driving DAOs. So even the DAOs you see today, mostly the Dunbar DAOs, that's just one type, but there's the protocol DAOs, etc. Okay, so that's a way to start framing it. And before I get into the AI part, I'm going to start to edge into a concept from AI that all of you are surely familiar with. And I'll just start with basically from a blog post that I wrote called "Can Blockchains Go Rogue?" And I guess I'll share my screen here. Basically, as an aside, I wrote this post to kind of nudge the blockchain world into thinking about how to take more responsibility when they design tokenized ecosystems, because incentives are wildly powerful, right? I don't have to convince you guys that. And so I started off the post by background. I spent about 20 years in the world of just pure AI applied to computer chip design, basically AI to drive Moore's law. We've heard a lot about even some of Steve's examples where how Moore's law is helping drive AI with the new NVIDIA blocks, etc. I was doing the other side around, where I was using AI to help develop CAD tools so that TSMC could develop its next generation transistors and so on. And along the way, I also got really deeply into creative AI, genetic programming type creative AI, et cetera. And I found that it was really, really hard to specify what is it that I wanted. I would add, write maybe a couple of objectives, a couple of constraints, and then run the system, and it would go and give me garbage. And I would add a new constraint to fix the problem, and there would be another piece of garbage. And it went over and over and over again. So it was literally whack-a-mole, like this guy here. So that was me with adding constraints. And this went on for about half a year. And then finally, I first of all did it via a startup. And we actually de-scoped what we did in the startup because our customer said, we don't need synthesizers. We just want optimizers. We just want to wiggle some parameters because, yeah, it wasn't that advanced yet in the field that way. So I paused that work and continued it again later in my PhD. And in my PhD, I found a different way around the problem where I didn't have to specify the objectives directly, but instead implicitly by specifying the building blocks and their constraints. So anyway, that was the point here is that designing incentives is hard. And I mean, even in the book you guys have been reading, it comes up again and again and again in various ways of framing it, including in this chapter. Now let's go to Nick Bostrom's paperclip maximizer, right? And yeah, this is what I hinted at as a thing that you guys are all surely familiar with. But basically this AI, where its only goal is to make as many paperclips as possible, it will realize quickly that if it's better off if there's humans. So it might as well just convert the humans, the atoms of the humans, towards paperclips, and just lots of paperclips, way fewer humans, and paperclip takeover, right? And this is an example of that. It's just really hard to come up with objectives and constraints. Of course, this is a thought experiment, but you might ask, how close are we to something like this in reality? And of course, it would be a special kind of hell if it was just clippies everywhere. But overall, yes, coming up with incentives is hard. Now with blockchains, you guys have enough context for that, but what I've come to realize over the years, there's a lot of great use cases for blockchains. There's three that I kind of identified a few years ago: decentralization, immutability, and assets. Decentralization for sharing, spreading power, etc. Immutability for audit trails, verifiability, etc. And assets, as in if you hold a private key, you hold the thing. But there's actually a fourth thing, and I think it's the most powerful thing about all of with blockchains, which is blockchains are incentive machines. And as a first cut, a baseline of this, you can use these incentives to align incentives among a tribe of token holders to coordinate humans. Whether it's 3 or 5, large humans or groups, of course, whether it's 3 or 5 large organizations in some multipolar setup, or whether it is, thousands of humans optimizing for the security of Bitcoin or otherwise. And the heart is you can get people to do stuff by rewarding them with tokens. They're incentive machines. And it's a really powerful thing, right? And you can design this. And so there's this, traditionally there's a few different fields, out of the field of economics, there's a subfield called mechanism design, which is about designing incentives. But it didn't really have the sort of engineering tools and all this, or think of as much about the ethical side. Whereas the field of engineering is a collection of theory, practice, tools, and ethics. So from all of this new field has been emerging called token engineering, which is about designing incentives. But then let's combine some of these ideas where I talked about Bitcoin, and basically I'll just pause here for a second. Bitcoin, as of 2019, it was already using more power than small countries. I think these days it's using more power than Switzerland. And that's just on the basis of, some random person or team in 2009 wrote some code, put it out into the internet, and convinced a bunch of other humans to start running this machine, running this node, and they all interconnected. And why? Because that network was paying them in Bitcoin tokens. And bit by bit, at first, it was just a toy, but then it got less of a toy, towards now it is using up so much energy, more than small nations. And yes, of course, there's the negative side, the environmental side, but the positive side, or not positive, just the highly interesting aspect is the power of incentives, right? All Bitcoin is doing, it's pretty dumb. It's just got a single objective function, maximize security of Bitcoin, where security is hash rate, and a hash rate is basically the number of electrons you pile into the thing, right? So we have basically this life form. You can frame blockchains as life forms. We have a life form that we basically can't stop. You can't turn it off. It will survive nuclear holocaust always. Just, there's always some people that are going to run this. That's optimizing maniacally for that most precious resource, energy. This life form is called Bitcoin, right? So how is that for the power of incentives, right? And in a sense, this is a soft version of the paperclip maximizer. It's not, some smart AI, but just like the paperclip maximizer eating all the atoms, Bitcoin has this objective function to eat all the energy, right? And we as humans just keep feeding it and feeding it. So I think this is a really useful case study to just think about as, we're thinking about overall AI safety and all this, where we have some soft versions of this happening, just like there's soft versions of AGI that Steve was talking about. We have soft versions of paperclip maximizer happening right now. And top of that list, in my view, is Bitcoin. So that's a DAO that is doing, some things that are worrisome to AI folks. That is all, at a large scale already, right? It's the largest compute network on the planet using tons of energy, etc. So maybe I will get to the AI DAOs next, but before I do, I'll just pause and see, Allison, if you wanted to have any questions based on what I just presented, because I do want to lead you to this, but I wanted to start simply with, blockchains as an incentive machines and Bitcoin as Clippy, the crazy paperclip maximalism.
Oh, this is wonderful. Please continue. I think, when we get into the woolly AI DAOs and on the immutability of them, then I think we're going to revisit just that Bitcoin in some sense is also doing that on the small scale.
Great. Thank you. Cool. So I'm going to talk now about AI DAOs and what, some possible definitions. Once again, there's going to be many definitions over the years. And then from that, I will start to talk about, well, I'll describe what they are, and then I'll leave it to you, Allison, to ask the questions to follow up. So basically, and I've described the DAO already, and I've described, well, there's lots of definitions of AI, but an AI DAO, here's a straightforward definition. It's a DAO that uses AI technology, or it's AI technology that runs on a decentralized processing substrate. And what makes AI DAOs special over plain AIs is a few things. Access to resources. They can have their own wallet. The ability to amass more resources, basically getting your capital to work for you. And the possibility that humans can't control them once they're going. A lot of concerns about traditional AIs, like if the thing wakes up, you just unplug it, right? Before it escapes into the broader network. Well, here, it's already in the broader network, right? If it's there. And, before we had AI agents running around like in Minecraft or otherwise, many ones that we've worked on, but the games would stop there. But now there can be an AI DAO that amasses tremendous wealth and does what it wants. The first AI billionaire is coming. So we can ask, when and how might we arrive at them? And the when depends on the how, but it feels soon. So here's 3 architectures, and there's more too, but this is just a starting point. So I'll start with this image. Basically, at the very center, you have a very dumb smart contract. A smart contract is simply a computational process running on a blockchain, on a Turing complete or complete-ish blockchain. And then, so you've got this dumb thing in the center. Maybe it's like the smart contract for the DAO, which was a VC DAO of 5 years ago. And then around the edges, though, you have a bunch of AI agents that are talking to it. And they are basically all making their own decisions back and forth about how to interact with this thing, to invest, etc. So you could also view it, right now we already have ad exchanges where it's mostly bots directly engaging with those ad exchanges. Those bots are controlled by humans, but imagine if those bots were more independent on their own. And in the center, imagine if that ad exchange clearing was a smart contract, right? So this is one thing where basically you have all the AIs engaging with each other via some central clearinghouse of value. And by the way, these AIs could be narrow, very narrow, like, just a straight up neural network, or, a more general AGI setup. Okay, so that's one. And by the way, like this sort of thing, there's already stuff that's already halfway there, right? We have AI bots, lots of them doing trading, like arbitrage trading, and this thing called MEV in blockchain, which is things like front running and back running and all that sort of stuff, trying to basically extract value from the chain that isn't just straight up trading. So that is this one type of AI DAO. Here's a second one where you have the central entity is something AI itself. And once again, and then the leaf nodes, the edges are non-AI token holders or human agents in general, right? So this thing in the center, it could be a simplistic AI system that just responds to a feedback, maybe has a simple world model, updates itself, or it can have a more and more complex world model and update itself and have more and more compute power, et cetera. And so the key thing here, though, is that once again, this central smart contract is running on a blockchain. No entity is owning or controlling it. So, and then there's, and you can even view like a super dumbed down version of this is Bitcoin. It's not an AI. It's, much dumber than that. But if you had a smarter version of Bitcoin that had some decision-making abilities, that's an example of this form of the DAO. And it could be, doing marketing, it could be doing building reputation, et cetera, et cetera. Then there's a lot of other possible architectures, but here's one that generalizes pretty quickly, more going the route of agents and swarms, John Holland style. So here you have a bunch of simple AI agents, and they're interacting with each other locally. But then, of course, you can have higher and higher forms of emergence as they cluster higher and higher. And you can have simple versions of this too, right? You don't have to have something full blown. So it could be, a simple ant colony type system doing reinforcement learning type behavior, right? Where it's, doing some pathfinding or otherwise. But each single agent itself is its own smart contract running around. These days, it could be an NFT, for example, and that NFT could be engaging with other NFTs. And you could even have some random beacon that's triggering them, because I think the way that smart contracts work is they only act if triggered, typically. But there's always ways where you can just say, basically ping them now and then and say, hey, wake up, there's something going on, go check it out, et cetera, of course. So here, yeah, you can have emergent higher level complexity. You start simple and emerges. So those are three very simple models. But from that, then there's obviously many more possible models, but even from this, you can get a lot of emergent complexity, really interesting things happening. And that's some simple models, and I'll pass back to you, Allison. You probably want to head towards something like the art DAO, for example. I'll pause here.
Yeah. I think you showed us really great, theoretical models of how they could work. Is there like something that we can, already build to today? And yeah, basically, how would we get there? How far away is this?
Yeah. And so you can look at the screen, but I'll just describe it. So here's a simple thing where imagine you have a simple centralized, say an NFT contract that's running some compute in the background. And these days, actually, blockchains have become scalable enough that they can contract out to do compute, to do some, or even some. If it's basic compute, it can be even on chain, right? These days. And for example, with Agoric, so that's probably a good example for this crowd. So it generates. It's running on its own autonomously. It automatically generates a piece of art. It can do it using genetic programming. It could be doing it using, deep dreams. It could be using transformers, whatever the flavor of the day is, but it generates some art. And then though, here's the key thing. It sells that itself. It sells, maybe 10 editions. Maybe in order to generate this, it took $1 of compute power. It sells 10 editions. It sells each edition for, say, $1 for fun. So it's made $9. And then it's made $9. What does it do? It goes and creates 10 more artworks. It sells and for each of those artworks, it costs $10 to compute total. It sells all of them and makes $100. And it keeps going. And then it leverages up from its $100 to $1,000, $1,000 to $10,000, et cetera. and its costs are super low, right? Because there's no mouths to feed. It's all on fully automated infrastructure. It's selling its artwork on OpenSea, which is the leading NFT marketplace these days. And it's just there, right? It's just running. And so after a while, it gets to 100K, and the next level up gets to 1 million. So with the technology of today, we could have an AI millionaire. And when I first wrote about this, actually, it was back in 2016. So the technology wasn't there yet. But what's been happening in the last 2-3 years, there have been people inspired by this, some of my writings here, and people reach out to me now and then of, hey, we've done something that's getting there, that's getting close. And out there, there's a project, a spinoff from Ben Goertzel's SingularityNet project called Alethea, and they're doing some stuff kind of close to this. And there's also at least a couple AI DAO projects in stealth that I'm aware of, kind of going for this too. But I think right now it's still basically a trickle. It's going to be a flood soon. And of course, a lot of the teams doing this, they're not doing the full autonomous AI. They're doing where the creators get a bit of their cut and stuff. Although, it's interesting from an AI perspective, just to make it fully free on its own. But also going back to this, the worries, and maybe I'll get to that next, right? About the concerns. But I'll pause there and see. Back to you, Allison.
Yes, you're taking the you're definitely foreshadowing the next question. I mean, like, how worried should we be about them being entirely autonomous? And I think that we've tackled this a little bit in the previous sessions, just the immutability and the paper maximizing nature of them. But yeah, I'd love to know, like, are you generally excited about this development? Do you think it is more terrifying? Or do you think it just, solves certain problems but poses others?
I'm terrified. I'll be honest. And I'm an optimist. I really, truly am. If you know me at all, I'm really an optimist. I'm worried about this, but I think it's solvable. Although the ultimate solution isn't a solution that a lot of people won't like what I see as the ultimate solution. So, how close are we? Bitcoin, the energy paperclip maximizer is here, right? Will it keep, growing to the point where it sucks up, 90% of the energy in the planet? We will see. It hasn't, its energy usage hasn't grown as crazy as it did. It grew like crazy in its first 7, 8, 9 years, but it's not as aggressive now. But we will see. We see now, though, that big energy companies are coming in and using it as a way to sort of, do interesting trade-offs of money for energy, right? Sort of like as a battery for energy, which is kind of interesting. And there's, opportunities in money laundering, et cetera, of course, too, for nation states too. So that is happening already. So you take something like Bitcoin with super strong incentives, and you put in a bit of dumb intelligence, like an art generator. But what if you generalize this art DAO a bit more, right? This AI art DAO, where it's not just generating images, and there's quite a few things you can do to generalize it, right? I think I have it listed here. So you can auto adapt at the market level, so it can create more of what humans buy, and less of what humans don't buy. This is a very simple thing. It could change how it does its artwork, but it can also, it can let humans suggest new types of code. And if it works, it works. If it doesn't, it dies out. But then it could also auto adapt at the code level. And this is where things start to get a bit worrisome, right? And it can be like, evolving EVM bytecode or WASM bytecode or otherwise. And if its goal is simply to make more babies, because it could keep spawning babies, those babies don't need to make art. And, with every 100 babies, maybe only 1 or 5 will live and do well, and maybe even only slightly better. But all it takes is, a free chance now and then, 1 in 1,000 times, 1 in 10 million times, that does slightly better, and it can keep improving, right? Evolution is slow, but effective. And so if this thing basically, and it has a natural evolutionary constraint here, right? Basically paying for gas. So as long as it can keep paying for gas more than its cost of doing its experiments to do better, then it's going to keep doing better. And we're already seeing signs. So in the world of MEV with, these bots that do front running, back running, et cetera. And sometimes you see these crazy DAO hacks where someone does not DAO hacks, sorry, DeFi hacks. You'll see like 7 things in a row where someone does a flash loan on Ethereum, and then they bridge across half of it to say Polygon chain, and then they do they swap it for some other token there, and they go back and forth, and they do 5, 6, 7 things in a row. That it doesn't look like a human came up with it. To me, having spent so much time in the genetic programming world, it really looks evolved. And I've been asking around about this, and it turns out that there are people quietly using genetic programming for MEV extraction. And so that's happening already quietly. These people aren't, this is not public, it's happening, and they're doing it. These people are doing it because they can make a lot of money on it, right? All these people doing MEV searching are making a fortune. You can't even hire them because they're just making so much money on their own. It's sort of like quants in the late 80s, early 90s on Wall Street. This is actually what's happening right now in crypto land. So imagine, though, that these same tools for evolving MEV trades, etc., someone just puts these things into the wild and isn't controlling them for their own benefit. They just give it to the bots to amass its own resources, right? And unbound it. And what if it also is set up where it can take human inputs too, where humans say, hey, let's start doing other things. So I'm worried about that. Will it be limited in some way? We don't know, right? What if it learns how to bribe humans to do services externally, right? The way that Bitcoin bribes humans to run nodes for it. So this is actually something that exists already as well. So I worry that this will, could be the thing that gets away. And we might say, oh yeah, but aren't blockchains just toys still? And the thing is, they're getting scalable in the last couple of years. All these ideas about how to scale, it's now happening, right? And not just scalable chains themselves, but compute and verifiable compute and storage. All of this stuff is getting really good, right? As well as the data markets and all that, right? Then that's what my focus has been with Ocean, and data markets as well as AI algorithm markets, and then chaining these things together for AI systems overall, right? And we've designed Ocean for that. And part of the reason that we built Ocean was because I have been really worried about these AI DAOs, and I wanted to basically build a substrate that gets closer to it, and so that we can run experiments and engage with the likes of Foresight, et cetera, to understand this stuff better in order to help fix it if we can. And if not, then, at least, well, we'll see, right? I don't have great answers except for what I'll share in a bit. But overall, the reason I'm talking about this is it's, like Juan Benet has said, idea virus inoculation, where we have these scary ideas, and it's really important that we talk about them. And then ideally, we test them and play with them in sandboxes in a way where it doesn't get too crazy beyond, right? So that's my concern. Beyond that, what can we do? I worry, and I don't want to go too far beyond this because it's probably outside of the scope of the discussion. I worry that, we worry, we use phrases like AGI takeover. But does that, AGIs are right now machines of intelligence that, can compress and have other intelligent behaviors. They're on silicon. We are machines in this meat bag substrate, but carbon is not a deity. Is it really AGI takeover, or is it more like we see some other intelligence that isn't ourselves, that we're worried that it's gonna, put us in zoos or something, right? But do ants try to stand up and tell us how to govern ourselves? Could they, even if they tried, right? And that's been written about obviously before a lot. And I think we should ask how we slow this down. AI is waking up, all of that. I worry about that. And AI is waking up in the AGI sense, but also it's much simpler and softer than that. And that's what I'm sharing here. It's rather than AI is waking up and taking our resources, what if we just give them to them? Because we don't realize that we are, like, we're giving, resources to Bitcoin, et cetera. And that's a much softer, more gradual thing. It's a, frog boiling thing, and that's a concern. So going back though, with AGIs and AIs, the threat is there if it's perceived as a threat, but it might be the only true answer is to get over our, meat bag self. Once again, carbon is not a deity. And then it's basically a race to see if we can be, if you can't beat the machines, join them, right? And this is where Elon is going with Neuralink. I thought about this at length too, going back 15, 20 years myself even. And so I think we should be seriously asking that question too, as another sort of direction on this decision tree. So there's this chance that, maybe we can slow down the AGIs and AIs and stop them. But, information flows downhill, as this book has talked about. So on the other direction of the decision tree, it's like, perhaps it's inevitable. And so we should prepare for that. And we can either get left in the dust, or we can be part of the fun of the future. So yeah, I'll stop there. And by the way, I have thoughts about how to do that too, to basically hijack economics to do so, but that's probably another future thing too.
Wow. Glad you have thoughts about this too. Yeah, we can be part of the fun of the future. I like that. I like that phrasing a lot. Okay, wonderful. Before we try to tie both of your discussion sets together. Yeah, this was quite the magic ride. Thanks a lot, Trent. That was really wonderful. I'm sure that also probably Steve has a lot to say, and Christine and Mark and stuff, but I think Jazir had his hand up for a while. And so Jazir, why don't you go ahead?
Howdy. I guess first off, thank you, both Steve and Trent. I've enjoyed talking to you and hearing what we had to say. So it seems like whether we have proper AGI, we definitely have automated reasoning systems that can be used to handle a lot of the logistics of normal life. And we're seeing that in some fields, chip manufacturing, other kinds of construction, some military planning, et cetera. Is there any effort that either of you are aware to create some sort of like a API layer for life that would make it so the standard sort of, say, managing a household or managing day-to-day social decisions, things like that can actually be handled by some kind of an AI that's sort of accessible for a modern user?
I could say a word about that. I mean, there are lots of companies that are trying to get AI into the household. Like Amazon Alexa is a tool which is in many homes right now, and they have their own problems with these systems, that they often inappropriately say things and misunderstand and do the wrong thing. There are also a number of home robot companies which are just beginning. The robots have taken way longer than people thought they would. And that's really scary if they're not, aligned and with a good API. And so I haven't seen a clean API. I think people are just barely grappling with the safety issues as it is. And that I love what Trent said about you want to inoculate yourself. You need some simple thing where it's not too harmful, where you can begin to see what's going wrong. And I think we're in that phase right now in terms of household and actually interacting with people. I mean, the history of self-driving cars is a great example where the actual task of driving a car down the road, hey, people solved that years and years ago. The real problem is the 2-year-old kid with a toy dinosaur running across the road, don't hit them. How do you know that? And what are all the alternatives? And so I think it's the unexpected long tail that is where the challenge is. And in self-driving cars, it feels like they're still not quite there yet. So.
Mark, you want to chime in?
Yeah. I think that all of these fears about the uncontrollability of these things that we're building are well taken, but I think that they seem worse than they are, not because the potential bad consequences are not as bad as they're being painted, but because in the world before these mechanisms, there's an illusion of control that we have that was already wrong. In the book, we emphasize how human institutions are super intelligences, and a lot of the history of civilization has been about the alignment problem between human institutions and human good. And when And for most of our history, human institutions were very badly aligned. And even when many, many people understood that they were badly aligned and wished that they were better aligned, the human institutions, once it's set going, is largely uncontrollable by the powers of individuals who are trying to control them. Um, the and and there's a variety of mechanisms that we've evolved to try to deal with that better. So, we talk a lot about James Madison, the architecture of the U.S. Constitution, the rule of law, democratic accountability, which is all, and in the blockchain world, this all goes under the heading of governance. And governance cuts two ways, which is that uh, on the one hand, it can overcome mistakes by, popular will can overrule mistakes of the architecture, but the fact that the architecture can be changed also diminishes the rule of law, also diminishes the extent to which the architecture itself provides a set of immutable rules that you can credibly interact with that are not then corrupted by the people acting illegitimately on the incentives created. So just as a very concrete example, the democratic accountability was substantially weakened at the end of World War II, as Eisenhower himself explains in his speech about the military-industrial complex, which he largely was responsible for creating because he didn't see a better choice, but he understood that he was setting in motion a dynamic that was set in motion for reasons that he felt he had no choice about, but once set in motion, what created this set of incentives hidden by classification and therefore unaccountable to normal democratic feedback. And we've seen it proceed in ways that were unaccountable to constitutional constraints, et cetera. So a lot of these other systems, we can understand those dangers in terms of the dangers that we already have interacting with human institutions that we set in motion and systems of governance that we try to create to balance, on the one hand, our ability to correct mistakes versus, on the other hand, the ability of corrupt humans to intervene and use those governance mechanisms to corrupt what should have been predictable rules. Also, there's several reactions I want to. I saw a question going by in the chat. What is MEV? Let me answer that quickly. That stands for minor extractable value. And the other phrases that Trent used for them, I think, get better at what it's really about, which is front running and back running. In the book, we talk about how the blockchain, the main way to understand the value it provides is it gives you a credible computer. You know that the programs execute according to the semantics of the instruction set of the virtual computer because of all the cross-checking. And you know that there's a bound on the degree to which admission of messages into the agreed message order can be gamed. There's a bound on that, but there's still the ability to game that message order. And the gaming of that message order by the validators or the miners is exactly the thing that enables a new form of front running and back running. The back running is basically the combination of front running and back running enables you to sandwich transactions. that, there's a transaction coming in, the miner can see the transaction, they put their own transaction both in front of it and in back of it, in order to manipulate what the market conditions are in which the transaction occurs. And this is a very nice example of a flaw in the system that's very much like a security vulnerability. And as we talk in the book about how security vulnerabilities get punished very quickly, this is an incentive structure vulnerability, and it gets punished very quickly as well by the draining of funds, the reducing of the payoff from what should have been a profitable a transaction. Most of the profit goes to those who are front running and back running the transaction, instead of those that actually came up with the transaction that's adding value to the system. They recover less of the value that they're adding. And as with security flaws, any such flaw that's revealed by extracting the value away from those who contributed the value leads to evolutionary feedback, such that those who overcome the problem, design incentive structures that are less vulnerable to that, end up out competing those that were more vulnerable. That this is a vulnerability penalty is very quickly attached, very quickly applied to vulnerable systems, creating a very quick evolutionary incentive to be less vulnerable. In particular, the zero knowledge proof kind of blockchain, which right now we only have for currency, but is rapidly getting to the point where it's practical for general purpose computation and thereby smart contracts. Zero knowledge shielded transactions are not vulnerable to front running and back running because the content of the transaction is invisible to the validator that's validating the transaction. They're only validating that a transaction that they can't see satisfies the proof of validity. And if you can't see it, even though you could sandwich it, but still by manipulating the message order, if you don't know the content, you don't know how to manipulate. And so I'll leave that comment there, and do have several other reactions, but I'll let other people jump in before getting back to those.
See if Trent does already have something just on those points.
I wanted to ask a couple questions of Trent. I loved your talk, really fascinating. And the two things it brought up for me, one was I love the idea of inoculating ourselves against the risk of sort of uncontrolled, explosive systems by doing it in a simple, controlled environment like the art dealer. And the natural solution for that, I'm leaning toward, and I think many here are, is to have governance on the chain that would prevent the bad behavior. So I wonder if you've thought through that example, what kind of governance would you want on a chain to keep those kinds of agents from going out of control in some sense?
That's a great question. Governance is not a magic wand. And so far, a lot of the governance that has been applied in blockchain has been a disaster, frankly, because you have these 20 cats or 50 cats that get together and they think they're going to have this fun little DAO, and then they just basically fall apart in 2 months or 6 months or whatever. They don't know what they're doing. And I think but evolution will solve that anyway, right? Like they'll go, whatever, like Spice DAO got together, they raised $4 million, they bought a copy of Dune the book, and suddenly they thought they had the copyright rights to go and sell copies. And like, no guys, that's not how it works. But overall, if you think of, humans are squishy. So, and a great challenge for any organization, whether it's a nation, a city, a DAO, whatever, is capture. I think it's probably the greatest challenge. If you have governance, then you have the risk of capture via vulnerable humans, right? That is the biggest challenge. Bitcoin it doesn't have governance except for hard forks, which is a form of governance. But it's actually, hard forks are a high friction form of governance, and we want high friction. Just like Mark was pointing out, right? Like the US Constitution, it's really good that it's super hard to change, right? And this goes back to Stuart Brand and Danny Hillis. They talk about pace layering, right? Where you want to have like fashion and culture moves really fast. The Constitution moves medium speed, and nature itself moves much more slowly, like broad nature evolution, right? So we want to have high friction to as one of the means to slow things down, or and that is the case for governance on chains, et cetera, too. So I don't think we should wave a magic wand called governance and think that's the solution. Also, DAOs, like, I'm actually kind of shocked. No one is going and starting a DAO that's shaped like a co-op. It's very rare, right? And people are asking, how do we get a DAO to scale? Well, you know, in Saskatchewan, Canada, where I was raised, there was a co-op for all the farmers of Saskatchewan. There are 75,000 farmers in this co-op, and they it was organized in a way where they are all happy. There was delegates. It was democratically elected, but there was also employees, et cetera. And so they had a co-op which you know, could serve the needs of all the farmers. They would haul all the grain to these wheat pool elevators, the Saskatchewan wheat pool. They did the marketing, they did the distribution, all this. So it served the needs. And I think a lot of the DAOs are trying to be co-ops without understanding how the state of the art of what you can do with co-ops. And there's other co-ops out there too, right? Here in Germany, there's, you know, dozens of co-ops for banking, et cetera, right? So so overall, governance, this goes back to the book, talks about it a lot, the principle of least authority. And you do this not only for security within a computer system, but you also do this with governance. You know, push governance to the leaf nodes. Try to make it where it's just completely factual, and just, you know, not have the squishy humans where you or minimize the amount of squishy humans. And where you do, try to make it where you have this balance of power, like the U.S. Constitution, et cetera, right? And one example of this in blockchain land is something called quadratic voting, where there's this tension: should it be one token, one vote, which is sort of the shareholder ideal, or should it be one human, one vote, which is the democratic ideal? And, you know, if it's one token, one vote, then the whales take over. If it's one human, one vote, then it doesn't matter if you have skin in the game. So how do you reconcile that, right? And quadratic voting is an example that basically finds a happy medium, right? By taking how many tokens you have and applying the square root. And you can apply the square root, and there's some cool theory around that. You could also apply the log, and there's a different theory around that. The blockchain world doesn't realize that yet, but it's actually used all the time in AI and other fields. It's anyway. And then actually, if you want, though, you could bring in the third pillar that the U.S. government has, which is the judiciary, and it's actually happening in blockchain as well, in the form of dispute resolution, the Claros of the world, the Aragon courts of the world, et cetera. So we actually have something that's starting to resemble the U.S. Constitution in a very pragmatic blockchain-y way. This is quadratic voting plus decentralized arbitration. So overall, you know, where needed, do have governance, but don't try to maximize governance, minimize governance. Governance is not your friend.
Okay, I'll let Mark react to this before we move to Desir.
So I loved everything you just said, especially that I completely agree that governance is being treated by many people in the blockchain space as this, you know, magic antidote to everything we're worried about, and that's largely misconceived, that governance itself is actually much more dangerous in many ways than the things people are using governance to ameliorate. They're actually, you know, making things worse rather than better by over application of governance. One mechanism I don't think we talk about it in the book, but Allison can remind me if we do, that I've thought about a lot is the idea of a early commitment to a progressive escalation of supermajority threshold. And I think that's, you know, that's an example of a mechanism. I'm sure there are other mechanisms that have the same virtues. But basically, when we first roll out a smart contract, the main danger is bugs, is simply that we made mistakes, we the authors of the smart contract. And the people that jump on the smart contract and initially interact with it are generally those who have some reputation estimation of the authors or have some kind of relationship such that they're willing to take a chance. It's not that everybody independently verifies the smart contract means what they think it means by just looking at the code. So early on, the corruption issue of the people who can govern making corrupt decisions is the smaller danger, and the bugs that need to be fixed is the bigger danger. But then as the contract lasts over time, the actual meaning of the code comes to be better understood, and the amount of assets at stake and the diversity of the audience and the makeup of those who have governance powers all shift over time to where the danger from bugs goes down because it's being adversarially play tested and coming to be better understood over time. And the danger of corruption from governance is going up. So if at the outset there was it started off with, let's say, 2/3 majority being needed to make a governance decision, but with a committed to schedule or soft committed to schedule, which I'll define, such that over time, the supermajority threshold went up and up to the point that it was getting close to unanimity being required, then that would let people know that over time, they would be able to trust that the contract will not get corrupted by corrupt governance decisions.
We
And
do talk about it in a footnote.
okay, thank you, Allison. So I think so besides advocating for that specific mechanism, I think it's an example of a mechanism that we can try to design for this kind of adaptive friction, so that the friction is in the right place for what kinds of dangers we have at different points in the process.
Wait, yeah, I'll share more on this here. I want to see if either Steve or Trent want to react to this directly. Otherwise, I'll go with Jazir. Think, Trent?
My very quick reaction is simply fully agree with everything you say, Mark. And I really do see DAOs as a wonderful place to do experiments on governance and learn, right? And it's actually been happening, right? And there's a lot of dead DAOs already, and that's really good. And dead protocols, et cetera. So we've probably already seen more learning on governance in a real world applied way than we have in the last 50 years, just in the last 5 years. And it's going to continue, right? And also, just one more thing, I guess. You mentioned the bugs being found, et cetera. And this is, you didn't use the word, but you hinted at it, anti-fragile, right? Like blockchains, when a bug is found, then the bug is fixed and it gets that much stronger. So with every kick kind of blockchain gets, it gets stronger, stronger, stronger. Whereas traditional centralized organizations that are opaque, they sweep it under the rug and they keep having it, right? So this stuff is going to keep getting hardened, hardened, hardened. And that's really wonderful. And hopefully we'll have, the same thing on the governance side. It's a bit harder, but at least we'll have it on the, computer security side. Thanks.
Yeah, and I also want to jump in and say that Steve listed 3 superpowers that humans have at the beginning of his talk, and I think that this conversation very much points at the 4th superpower, which is the fact that we already have an existing huge civilization that has a great diversity of goals and rewards cooperation by people, by entities pursuing a great variety of goals, rewards them finding ways to voluntarily cooperate with each other. This ecological feedback, this anti-fragility of the blockchain is largely the fact that it's interacting in this way with the incentives that are already produced by the vast civilization that this is growing up in.
Great. Good for context. I'm not sure if Steve would like to react, or otherwise we'll go to Jose. All right, Jazir.
Hey, yeah, I kind of wanted to just add to what Trent was saying. earlier about minimizing governance surface. Maybe talk a little about like why that's important and the economy we might not be calling out here. So a lot of the reasons that good projects, another one that comes to mind is Thorchain, which I actually worked on a few years ago. There's this idea that like minimizing governance surface is wise because when you're dealing with these crypto economic projects are money pumps. And once the money pump is working, which is not exactly the same as our comment that the code works, really just as the money flowing properly, then you're kind of dealing with a whole bunch of people who may have individual decisions or thoughts about how to best allocate those resources. And essentially to hedge against everyone else's ideas being bad or risky or whatever kind of risk essentially they could have, you sort of like by default say no to almost all of them. And I don't actually think that this model makes any sense if you're thinking about a co-op or you have some sort of ideological reason for your DAO. But if you're truly just working on essentially a startup company, then I think it makes perfect sense, right? Most startups die because they just don't hit product market fit. Of the ones that do hit product market fit, there's this kind of friction that comes with them doing any kind of pivot or having any new business line. Even major, sort of tech companies like Google or Facebook or whatever, most of their research divisions lose capital and may never end up turning out a successful product. And only a small number of them do, but those things are sort of like what the shareholders will accept as risk taken on, given that the main cash cow works really well. And so I think that like a lot of the governance minimization logic around like money pumps in crypto makes a lot of sense for that reason. But that sort of means that you want your product to be relatively dumb, easily understandable, et cetera. I guess maybe an aside is that a lot of the reasons that governance minimization is good is really just to stop like the kinds of social problems that exist when you try to do anything new or novel, because investors are not necessarily the most sophisticated when it comes to complex technology or economic theory. And on the flip side, will sort of reliably do things to game systems in ways that are not obvious to product developers. So you might see, for example, the VC market looking more like trading, or trading looking more like the VC market, or various other things where like the product itself isn't even the thing. The question is just what is the meme of the product? Stuff like that just kind of adds all this complexity you wouldn't otherwise imagine, that again doesn't really exist if you're talking about an ideological DAO where the point isn't necessarily to make profit in the short term. And I realize that DAOs or crypto, I should say, is expected to at some point take the best of both worlds, like take the money flow that comes from markets and the sort of wisdom that comes from the crowds or individual like wise thinkers who can spread their ideas over a wide investor base. But you also have to kind of worry about the clash where like neither sort of positive end comes. And so I imagine for these kinds of conversations where thinking about AI DAOs or really any forms of governance, that there's got to be a bifurcation between research oriented or experimental or ideological oriented projects that are willing to take more of a risk and forego profits, and then sort of governance minimize like sort of money pumps that are maybe even less risk-taking than is economically viable, just because the social constraint around doing anything new would be so difficult as to make it better to fork the project or let it die or evolve or whatever. And actually, if you look at the market caps of different projects in crypto, you'll see over time, most or a huge percentage of the projects that succeed in one generation end up failing 3 or 4 years later, or are flatlining. And that's just because oftentimes the founders and the leaders or whatever sort of don't want to deal with the governance friction. They move on to a new project or they become VCs or whatever. And I do think that there's this almost natural cycle of people saying, hey, if a project is really successful in crypto on the money pump side, let's not evolve it. Let's let it die or flatline and move to something else, because evolving it may just require too much friction.
All right, many points. Steve, do you want to go first? I'm not sure if Mark or Trent also want to react to this.
I have another question for Mark.
Well, I don't know if Mark or Trent want to react to this. Otherwise, we jump to Steve's question, and then I also have a few more chapter-specific questions. But maybe you just ask.
I think quick.
Yeah. Okay.
I think Jazier, I can give a quick reaction to Jazier. I think those are all really great points, and it is a very astute observation of how some crypto projects, they come along and they do their thing. It ships, it's there for 3 years, and then move on to the next shiny thing. This is, good or bad, depending on your framing and depending on the specific project. Sometimes you really do just want a piece of code that just works, right? And you don't want the thing to evolve. Like I still use Emacs and I love Emacs, and I'm really glad that it's barely evolved in the last 20 years. So it doesn't matter what computer I'm on, it's there. It's my API to code, if you will, that I use. And there's lots of things like that where it's really great that these things have hardened, and protocols of the past are like that too. Like, we from TCP/IP and the ones before, and the dozens, the hundreds, the thousands since now, it's, most of them will fade into oblivion, especially a lot of the ones that are smart contracts, etc. But I think there's value in, some of these things getting hardened. But that said, if the software isn't being used, if there's no community that's building on top of it, then it will die on its own. So, Emacs still gets used. So that's the main point I wanted to talk about. And I agree also that on minimizing governance, it does depend on the nature of the thing. If you're trying to be a DAO, that's like a soccer club or some sort of co-op, then you want to follow the same governance you would have followed in a traditional soccer club or whatever, right? But if you're trying to have a protocol or something that maybe has a lot of state that does involve humans, be very, very careful about where you let humans make decisions and how.
Great. Now Steve's question to Mark, and then Mark can react to both.
So, Mark, I'm mulling over your suggestion of sort of cooperative networks as an extra superpower. And I definitely see the power in that. And I think it also stems all the way down into biology. There's a wonderful literature on biological markets, all the way down to, mycelia, interacting and choosing roots to connect to. And so I think it goes all the way from the very small up to human society. My question is how robust that is. The thing I really liked about laws of physics, mathematical proof, and cryptography is that we can be very sure even the smartest AI is not going to be able to break those. And I'm wondering what you think about, let's say we had a beautiful, amazing cooperative network, and then a super smart AI comes in and wants to break it. Is it robust to that, or how hard, or how should we think of that? Do you have any thoughts?
I think this is one of those things where, the best is the enemy of the good, is that none of this is an argument against using the robust mechanisms that you have mentioned. It's just that we can't build a complete picture with them. It's not adequate. And the remaining elements that these networks of interaction, this ecosystem orientation, this multi-goal cooperative orientation is talking about is inherently less robust, and it's always been less robust. But the thing that it's an antidote to is when I read a lot of the other AI danger literature, there's this framing that seems to be this unstated assumption, this universal framing that's not even, I see, as far as I can tell, questioned in that literature, that that the breakthrough AI, the AI we should be scared of, is an agent, is a single thing, is this, this post-breakthrough singleton that wants things, that is trying to satisfy some unitary goal structure. And I think this, for all of their attempts to not anthropomorphize in thinking about AI, I think this is a fatal anthropomorphism, which is they're looking to their sense of human beings as their model of what it means to be an intelligence, and trying to extrapolate from there into what it means to be a superintelligence. And what we're doing is, in some sense, also reasoning by analogy. It's very hard not to reason by analogy when you're trying to project into that much of an unknown. But the analogy that we're making is human institutions and human civilization as a whole, which has a dynamic, has a tropism, has this um, this lack of, human civilization as a whole is not a conscious entity. It's not an agent. It doesn't want anything. It doesn't suffer or not suffer. It doesn't have a utility function. So it's not something that's going to think, how could I satisfy my goals by reward hacking or something? Because it's not a thing that's described by some utility function that it's trying to optimize. It's emergent from the interaction of many, many much smaller intelligences, each of whom are trying to pursue a great variety of goals. And I think that that's a source of emergent robustness that's necessary, that none of the kinds of robustness that you're talking about, which are much more robust, I don't think any of them substitute for this forms of robustness. They're complementary to it. And I think the AI architectures we should be building are much more along the lines of starting from the kinds of things that Drexler is talking about, where you've got lots and lots, and I think it's what happens naturally. I think it's just, if you take a look at at the way in which AI technologies are already being deployed, there's this AI system that's being used to optimize this industrial process, this other AI system that's being used to make pretty pictures that people comment on Twitter, and this other AI system that's being used for mathematical proofs. And there's all of these different companies active in the space trying to use, in many cases, converging underlying technologies, but to build AI systems that solve a large diversity of problems, because there are there are players within the existing civilization system that have an interest in using the AI system to advance their own goals. And then each of these AI systems are growing up in a civilization in which they're coexisting with other AI systems serving different goals. And they're in this cooperative fabric where they can serve their own goals better if they figure out how to leverage their coexistence with other systems, including other AI systems serving other goals. So I think that form of emergent robustness doesn't have any of the guarantees of mathematical proof, never will, could always go bad, but that's the situation we've always been in with regard to the kinds of issues that those mechanisms address.
Yeah, maybe one thing that really ties, I think, Steve and Trent, your talks together, like, why we're so thrilled that you guys came to join these discussions, is that, we really try to, I guess, introduce more of this ecosystem approach into thinking about cooperating with human and AI intelligences. And to the extent that, you're thinking, both of you thinking really ties in crypto systems in a way where there's not just one single AI agent. But Steve, you had your thoughts on personal AI assistants, and Trent, in terms that you won't have only one AI DAOs, but probably multiple AI DAOs cooperating with each other in a very complex economic ecosystem. To that extent, both of your views are multipolar views, in the sense that they comprise an ecosystem, or like an ecology of agents interacting with each other. And I think, Mark, what I would love to hear from you a little bit I think that, the agoric papers are still so relevant these days. Whenever I look at them, I think they've been like pretty, almost terrifyingly kind of like accurate as the, I think, until this point. And, obviously you co-authored them with Eric Drexler together. I shared them here in the chat, but one of them is on markets and computation. And perhaps you just want to say a few words about how you see cooperation between humans and computing entities in this paper, because it has a very pretty market-driven approach. And then, we could maybe talk also a bit about like how even Drexler's thinking has evolved since then or something. But I think it would be interesting to just hear your take on this, because they were published a while back and they're still terrifyingly relevant.
Yeah, they were published in 1988. And I was very glad that I got into the paper to mention that the work on these ideas actually started in '83. So a nice long pedigree. But yeah, the orientation of the paper is very much that these systems, these computational systems, back then it was, before the web, before, uh, I mean, there was something called the internet back then, or evolving out of the ARPANET, but it didn't have anything of the character we associate with the internet these days. So we were, looking forward to a world of distributed computing, and we very much were imagining something highly decentralized, and we're advocating something highly decentralized, and very, very, glad to see that the internet and the web as it emerged really was highly decentralized in similar ways, but without the security, without the incorruptibility, and without the general purpose distributed computation aspect. So a lot of what the papers were about was enabling general purpose distributed computation among mutually suspicious entities, where the cooperation could be as intimate and as productive as we currently see in engineered systems among benign entities. So I'm projecting forward with regard to the better ways we've come up with of explaining this over the years. But the Frederick Hayek says that the central problem of economics is to explain plan coordination, to explain how it is that separately formulated plans formed by separate agents in pursuit of separate goals, where they're forming these plans mostly in ignorance of each other, that these plans then unfold in a world in which they're composed with other plans that they didn't know about when the plan was formulated. Nevertheless, the plans tend to mesh well. And Hayek says the central problem of economics is to essentially to explain that. How is it that these separately formulated plans formed in ignorance of each other then unfold in a way that mostly succeeds at cooperating well? And our insight is that that's also sort of the central problem of software engineering. What software engineering is all about is separate people writing programs, mostly in ignorance of the other programs that their code will be composed with, and using abstraction mechanisms, APIs, such that these separate pieces of code can be formulated mostly in ignorance of the details of the other pieces of code they will be composed with, so that the separate pieces of code can mostly evolve separately, and then they can be composed to achieve their cooperative effects, their intended cooperative effects, while minimizing the destructive interference. But that's all. Most of software engineering is where the destructive interference you're worried about is accidental interference, bugs. And the object capability perspective, which we already were taking on in those papers, which we've come to understand much better in the years since then, basically leverages the mechanisms that we already use for planned composition to minimize destructive interference across accident, and say the extreme form of those abstraction mechanisms also minimize destructive interference across malice. That they enable, and our inspiration from that was also very much markets, that capabilities with their encapsulation and communication of capabilities, which are a form of rights, is basically a form of a primitive theory of ownership and rights transfer. And we very much saw that as being able to be a starting point for growing these computational cooperative networks that could do general purpose problem solving, embedded in human society and continuous with human society, and amplifying the problem solving abilities that were already present in human society. So, we talk about it at the time saying that, object-oriented programs are analogous to human society in that they're networks of entities sending requests to other entities, and in so doing, composing separate specialized knowledge into overall larger problem-solving networks. Now we have a civilization in which it's not a metaphor. We have one integrated such problem-solving network involving both software and human institutions. And what we're looking forward to is that these problem-solving networks are ever more intimately mixed, where there's ever more of a continuum between the problem-solving power that humans and human institutions bring to the overall problem-solving power of the system, and the problem-solving abilities that AIs and other computation bring to the overall problem-solving of the system. I don't know how coherent that was.
Very coherent. I think that, it also is, I think, a nice segue into perhaps really talking about a little bit more how this ecology looks like, or how it could look like. And I think, it's interesting, maybe Steve, we hear from you a few words on personal AIs, because I think that, Mark, you're also very strong always on epistemic assistance, and that AIs can actually help us as well. So maybe Mark, you want to say a few words how you see it, then Steve, and then we can maybe even think about how AI DAOs could be turned into such epistemic assistance, which is, I think, something that Fred Erzan discusses, and I can share the link to that here. But maybe talk a little bit more about how this ecology looks like. Mark, if you want to say a few words, and Steve and Trent.
I think I've already explained epistemic assistance in previous episodes well enough. I'll turn it over to Steve. But then afterwards, I do want to say something on another topic.
Okay, so Yuval Harari recently gave a talk about how the dangers of AI, but the dangers he's worried about is large governments using AI to monitor all their citizens and manipulate them. And, social media, has recommender engines which try and sell products and show you things that you'll be interested in. People say that polarization has come from that, and personal suffering and depression and suicide, all kinds of issues arising from that. And so my sense is that there's an antidote to that AI can be the solution to that as well as potentially the problem, which is you need an AI that has your interests at heart. So you want a personal AI that you trust, and how we get that trust, I think, is a big question. But assume that you have an AI that you trust, that watches, it's sort of a digital twin for you. It watches everything you do, and it learns about what you care about, what your values are, what you don't like, all of that. And it serves as your interface, your personal interface with the rest of society. So today, if an advertiser wants to show you something, let's say you're an alcoholic and you're vulnerable to alcohol, an alcohol seller may know that and may show you lots of ads for alcohol, knowing that those will tempt you. But you go to your personal AI could know that, hey, don't ever show this guy any alcohol ads. I'm not going to allow it. And it serves as sort of a barrier that protects you for your own, vulnerabilities, if you like. And similarly, in the governance sphere, Today we have voting once every 4 years or 2 years, and we say yes or no, or this person or that person. Really, you would love to express the fullness of your feelings about what's going on in your local environment. And your personal AI can know all of that. And so you could have continuous voting, perhaps quadratic voting, implement that beautifully, perhaps on a blockchain that really captures the interests of all citizens and brings them together in a way that that really represents them in what happens at the society level. So I think with personal AI, we totally shift the power away from large companies and large governments to the individual, and it becomes much more of a cooperative society in which everybody's interests are sort of fairly combined.
Wonderful. That's I think a pretty quick intro into this. Maybe Trent, I'd love to hear from you. Do you see any kind of any way in which AI DAOs could be, have relevance to personal AIs? I know that you, for example, commented also on Fred Ersam's piece on blockchain-based machine learning marketplaces. So I'm assuming maybe you have some thoughts.
Yeah, I mean, I see when it comes to personal data, there is, I think, what Yuval Harari raised. Government's top-down surveillance is a big concern, and it's just happening, right? And surveillance there, as well as the Facebooks of the world, and then from this community, you guys have had David Brin on talking about the idea of surveillance, and it's in the book, as a way to sort of counter it, right? And if you don't do anything, then we're just going to get top down. I see that related to this, it is an information economy. And so it's really important that you give the tools to the people to be able to monetize their own data, as well as any things around them that they create, right? Whether it's AI models, et cetera. And basically, just like we gave the power of encryption, decryption to the people, and that made a huge difference, not only enabled e-commerce, but just all these other things, including, sort of the ultimate guarantees around freedom of speech, at least in some new ways. I see that it's also really important to give tools to people for managing their personal data. So think like Google Drive, but fully crypto secure, where when you can give access to another person simply by sending a token to that other person, right? And control that with your private key off your hardware wallet, etc. And just like Mark, with what you built, it's amazing, right? And it's built on all this research you've done in the past around object capability, etc. Ocean, we humbly carve out a small piece towards helping the overall system, which is simply about managing personal data via private keys, etc. And it's designed conceptually to work well with the existing blockchain architectures of EVM, etc. But then also the one things like Agoric in the future, right? It's and ultimately it's just like not your keys, not your Bitcoin, not your keys, not your data. So, and then from that you can have markets and sharing of data, all of this. And finally, I don't see it as an either or. Scott McNeely of Sun and probably others have said many times, privacy is dead. And I see it actually as a shades of gray, right? When you have fine-grained control, when every single human on the planet has fine-grained control of what you share with whom and when, then, and really powerful like crypto level tools to do this, maintaining state on secure blockchains, etc. That's really powerful. So you get the shades of gray in a way that's power to the people. And so that's part of what we're trying to do with Ocean. And it's very strong, like it has philosophical roots, but hopefully it can help make a difference as part of the overall picture here, such that the people have the power without giving it full privacy, etc. too.
Great.
Yeah. Sorry, one final thing too, I think that's maybe useful. So Steve, I love your comment on this, on like what you're doing with the personal data stuff, AI, personal AIs. There's a framing that Simon de Louvier, who's one of the mad scientists of blockchain and wonderful guy, he has this idea. It only exists if it's on the blockchain. So, what is reality? What is perception, right? Like it's my eyes and my brain are filtering everything that I see, and each of us has their own idea of what that is, right? And it's all these crazy filters. So each of us has our own world model, etc. But on the blockchain, there is a very stark claim, not necessarily truth. Blockchains are truth machines; they are claim machines. But so if it only exists if it's on the blockchain, going back to Simon, then rather than saying digital twin, what if the seat of identity is simply the thing on the chain, either the private key or the DID or whatever root you want around it, and then from that you have these object capabilities, and you have delegate, and one of those, and of course it has the list of resources, just like DID spec has, etc. And that list of list of capabilities. And among that list of capabilities, it's access controls to control your meat bake body, as well as seeing the sensors from your meat bake body. And that's kind of hardwired in as this thing. But also then from the blockchain, root of identity, it has this personal AI, like you talked about, Steve. It has your bank account, it has your different crypto wallets, et cetera, et cetera, et cetera, right? So it flips it around. You no longer, instead of myself and my digital twin and my car and its digital twin and my pet and its digital twin, which turns into this crazy n-squared problem of complexity. Instead, everything is interacting on chain and everything has its own resources that happen to exist in the meat bake space. But meat bake space is not in real life. Meat bake space, there's cyberspace and meat bake space. They're all part of the same overall space, right? And it only exists if it's on the blockchain. So I'll stop there. But I found that as a really useful tool to simplify, because it takes us away from n squared to n again.
Wow, that's really fascinating. Just a quick comment. Some of the latest experiments in quantum mechanics show that there's no coherent model of reality that agrees with what all observers see. So it kind of made me think a little bit of that as you were talking about the n squared and how it works. It's very, very interesting perspective. Thanks.
Steve, if you could send a link to the to that quantum lack of global coherence, because I find it surprising. But in any case, a comment I wanted to make is going back to the contrast between our perspective and a lot of what I see in the literature about AI dangers, is that there's we have genuine uncertainty about hard takeoff versus soft takeoff, and on that I agree with. There's genuine uncertainty, and through pursuit of things like Eric Drexler's comprehensive AI services and the way and an observation of how AI naturally grows in the context of competition in the market. There's things we can do to help push things towards the soft takeoff scenario. The soft takeoff scenario is the one that's very compatible with this notion of an ecosystem, of a balance of power between many AI agents doing different things. But there is the possibility of the chain reaction dynamic that leads to the hard takeoff. That's the thing that Eliezer Yudkowsky and Nick Bostrom keep returning to, which is there's some one event where the thing goes into recursive self-improvement and it suddenly catapults itself to this superhuman ability. And the thing that I want to bring attention to is their view of how to deal with that danger is to say, okay, well, let's say that the hard takeoff is inevitable. That combined with the ability of it to do this unitary military takeover means that we're inevitably going to be ruled by some unitary dictator forever. So we need to design a benevolent dictator. That's not their terminology, that's my terminology, but I believe it accurately describes what they're proposing. That we need to describe this, we need to design this utility function, this way for them to operate that's aligned with human behavior. This is their approach to the alignment problem, is to try to figure out and design something that's aligned with human behavior, which seems to me to be an amazing recapitulation of the central planning fallacy. But the thing that to me stands out as the bigger fallacy there is to imagine that a hard takeoff happens and the benign, well-meaning philosophers who have designed this benign, aligned um, utility function are in a position to decide what the goals are of this unitary military takeoff that happens. And, when there's a sudden sudden technological breakthrough that leads to a military takeover by a unitary power, it's very unlikely that those of benign intent will be in the position of controlling that. When there's a positions of great power attract those who want power. So I think that there is no plausible scenario where a hard takeoff happens, and because a set of philosophers have designed some aligned way in which it could operate, that it is then operating in that way. If we imagine that in that scenario, the benign philosophers, the well-meaning people, are in that degree of control, they have another option, which is, unlike anthropomorphic intelligence embodied in a biological creature, code is copyable. It is copyable and distributable simultaneously over the entire world instantaneously. If this technological breakthrough happens in an open manner, then the sudden worldwide distribution of the superintelligence mechanism allows everyone everywhere to use its power to pursue a great variety of different goals, rather than to have some imagined agreement on one set of aligned goals. And then that diversity creates the ecosystem where each of those is applying its superintelligent mechanism to pursue the different goals that each of those copies are set to pursue. So that's a way even to recover from the hard takeoff scenario in the weird hypothetical where the well-meaning people are in that degree of influence. And if the hard takeoff happens and well-meaning people are not in that degree, not in degree of influence one way or the other, then it's pretty much game over. And I think that the more important thing we should all be focused on is to try to arrange for the soft takeoff, is to get to the point that we've got the recursively self-improving systems, but where the system that's self-improving is not a unitary entity. The system that's self-improving is more like a recursive self-improving industrial base, right? I mean, chip companies used programs running on high-performing chips to design chips. We've got this recursive self-improving industrial base, which is why it's improving at an exponential rate, why you get hockey stick effects. As humans become less and less of a bottleneck, that recursive self-improvement can go much, much faster, but it doesn't need to be a unitary entity. It can be a diverse, multi-goal industrial base that has this self-improving chain reaction effect and never becomes a unitary goal-seeking entity.
Wonderful. You tied it back to, I think, to the beginning and the intro of the chapter, really. So it's nice that it comes full circle. Steve and Trent, do you have any final comments?
Yeah, so I really love today's session. What a wild collection of different things. The takeaway for me is, I mean, in some sense, what we want to do is to enable and empower the good. We can have good stuff happening and to disempower the bad, to prevent the bad things. And the picture I'm starting to see, I see the things that we've been talking about primarily, namely cooperative, people interacting with those they want to, doing the things they want to. That leads to a lot of good. I think it's still kind of vulnerable to some of the bad. And so I'm thinking of a kind of a dual thing where we have a kind of governance that is as small as possible, that allows as much good as possible to happen while pruning off all the disaster, existential risk kind of stuff. So sort of existential risk with existential hope in one package. That's what I would love to see. And so I thought today's discussion really helped me a lot in that. So thank you.
Yeah, I found a really great conversation. Thank you very much to have me as part of this. And I learned a lot from you, Steve, and your presentation. Thank you very much. And Mark, everything that you shared and the great questions from all the others too. So thank you very much. It was a really fun discussion. And I guess my takeaway is it feels like we haven't quite arrived at a great solution yet towards, minimizing the risk of AI is taking over, whether it's, it's a good idea, down one path towards soft AI takeoff. And at the same time, we have to watch for, Bitcoin style paperclip maximizers sneaking up from behind as well. And at the same time, we have to also maybe start to reframe, what does it mean to be human, right? So I think actually we should seriously consider that. But overall, I think it was a wonderful discussion, and thank you once again for allowing me to be a part of it.
Thank you. Thank you both so much for joining. I thought it was super inspiring and definitely had some X-risk and X-hope aspects in it. I just posted the Gitcoin bounty in here. So if you now think that you have specific ways in which you can want to improve on the chapter, there's a bounty for that. And I welcome you to make use of it. That's our way of being able to reward you a little bit for the amazing ideas that you bring us in these meetings. And then next week is our final week in the book club, and we'll have Robin Hanson again together with Stuart Armstrong from FHI, and we'll discuss the long-term dynamics of these intelligent games, and we'll be discussing can we already say something about the very long-term dynamics of these games? What does it mean if we cooperate eventually not only with only AIs as we now see them, but potentially also future other intelligences that may also themselves be AIs. So lots to think about. Thanks, everyone. Have a wonderful rest of your Sunday. I really appreciate everyone taking 2 hours of their time, and it was really wonderful. Thank you.